Okay, so today I will show you how to make this custom 7-segment display, and it's quite special project because you've probably already seen it on a thumbnail. You don't need to do any soldering. And it's not that I don't like soldering, I just wanted to make this project as simple as possible. Which means that if you want to follow along, you don't need to do any soldering, you don't need to use any screws, any glue, you don't need to have any special equipment. I think you get the point, right? So let's maybe talk about what you do need. You need to get the NeoPixel LED strip, that's this thing on the reel. You need some way of controlling those LEDs, and I'm using the Arduino UNO because it's cheap, simple and easy to use. And then you need this 3D printed enclosure. And if you have a 3D printer, that's great, you can 3D print it by yourself. If you don't have 3D printer, that's not a problem either, because you can use PCBWay and get it printed from all the different materials. And you've probably guessed it, PCBWay was kind enough to sponsor this video. They not only offer 3D printing, but as the name suggests, also PCBs and PCB assembly, but also things like injection molding or CNC machining. And I was wondering how would this 7-segment display look like if it was made from metal, and well, it would look like this. I think it would look great. So again, thank you PCBWay for sponsoring this video, and let's get back to our project. And let's start with the LED strip. Those are NeoPixels, the individual addressable LEDs, and they can display any color you want, and you only need one wire to set the color for as many NeoPixels as you want. That's the reason for having 3 wires, so the 5V and the ground is for power supply, and the data, well, the data is for data. That's how you control those LEDs. The LEDs are placed on this strip, that's the PCB, the printed circuit board, and it's a flexible PCB, which means that you can bend it easily in this direction. But as for bending it in the other direction, you can bend it a little bit but not too much. And for the 90-degree angle that we might need for our 7-segment display, that would surely be a problem. What you need to do in that case is to cut the strip on those exposed pads, position it in the way you want it to be, and then solder those connections again. So those 3 pads, the 5V, ground and the data, needs to be soldered again using 3 wires, which means 6 solder joints. And if we look at our 7-segment display design, we need at least 5 of those corners. And if we want to create a digital clock with 4 digits, you need to solder quite a lot of connections. Because 4 digits times 5 corners times 3 wires times 2 solder joints per each wire, that's 120 solder joints, and that will surely take some time. Thankfully, we are not the only one with this problem, and that's the reason why you can buy those connectors. You just put the strip inside on both ends, and then you just close it like this. And you have a 90-degree connection. The thing is, this is still not simple enough. You have to buy those connectors, you have to cut those strips, and you have to put everything together. So I was searching a little bit more and found this LED strip. And there are many different names for this strip. Sometimes it's called the S shape, sometimes it's called the zigzag shape or snake shape. And that's because the PCB has a certain shape that looks like a snake, and this should allow for easy bending. And indeed, the 90-degree angle should not be a problem with this kind of strip. If you look closely, there are also exposed pads after every third LED, and on this place we cannot bend the strip, at least not very easily. So this kind of dictates how many LEDs we need to use for every single segment, which would be the multiplies of 3. And I will actually use exactly 3 LEDs for every single segment. So after a little bit of bending, the LED strip might look something like this. We will be not using the very first LED, that's probably fine, and then we have 7 segments, each containing 3 LEDs. So I think that at this time it's time to create the 3D printed enclosure. I'm using Fusion 360, actually it's just called Fusion now, and you can use it for free for personal use. And in here you start with the 2D drawing, with the 2D sketch, so I'll click the Create Sketch button, and then click on the bottom plane. Now what I want to do is to create this one segment of this 7-segment display. And for that I will select the line tool and start drawing the shape. So for example, something like this looks like our segment. And we set how the shape looks like by using constraints and dimensions. And the constraints are those tiny icons, and you can see that some of those icons are already in there because as we were drawing, the Fusion was trying to guess what we are trying to do. So for example, for this top line, we have this icon, which is this one, which is horizontal/vertical. So if I drag only one point of this line will always try to stay horizontal. And then we have this constraint, which is this one, which is a parallel constraint. And this is saying that the bottom line will be parallel to the top line. And because the top line is also horizontal, as a side effect, the bottom line will also always be horizontal. To get to our final shape, we need to add more constraints and dimensions, but not too much. And I can, for example, say that this line and this line should have the same length, as well as this line and this line. And for that, I can use the equal constraint, so this line and this line should be the same, as well as this line and this line. But I also want to define some angles, and I know that this angle should be 135 degrees. So I'll select the Sketch Dimensions tool and sketch the angle between this line and set it to 135 degrees. And the same angle should be in here, so this line and this line should also be 135 degrees. I also know that this line and this line should be at 90 degrees, and I can use the same Sketch Dimensions tool. Or what I can do as well is to use this constraint, which is the perpendicular constraint, which also sets the angle to 90 degrees. So perpendicular constraint between this line and that line will give us 90 degrees, as well as between this line and that line. And I think that at this point, if I try to drag some of those corners, I'm only changing the size of the shape, but I'm not actually changing those angles. So I think that this is something that I'm looking for. All I need to do is to set the overall size of the shape. And for that, I will again select the Sketch Dimensions and set the distance between this point and this point to be 61 millimeters, because that's the size that I've measured. And I want the distance between this line and that line to be 20 millimeters. And I can always select the selection tool and move those distances around if they are going into my way, but this could be one segment of the 7-segment display. Now imagine that I have 7 of those, and maybe I've decided that this distance should be different. In that case, I would have to change it in 7 different places. Thankfully, I don't have to do that because I can go to Modify and select the Change Parameters, and I can click the plus icon and add my own parameters. And let's just name this segment length and use our 61 millimeters. And add one more, and this time will be segment thickness, and set it to our 20 millimeters. Click the OK button, and now instead of using those hard-coded numbers, I can delete this value and type in segment length. Click the OK button, that will stay on the same value, but now it's using those parameters. And for that one, I will double click as well, delete the value and type in segment thickness. So now if I copy and paste this multiple times, like this for example, let's just do it one more time so you can see what's going on. I can always go to Modify, Change Parameters, and if I change the value of length to be, for example, only 50 millimeters, all of those segments should update at the same time. In the end, I ended up having a sketch that looks like this. There are quite a lot of dimensions and of course quite a lot of constraint, because not only it has those 7 segments, but also the outline. By the way, the outline is made using this offset tool. So once this 2D sketch is finished, I can click the Finish Sketch icon. And I can create a 3D model from this 2D sketch using the Extrusion tool. So select the Extrude tool and start clicking those individual segments like so, until all the shapes are selected. And I've used the 0.8 millimeters for the distance. So if I hide the sketch, this will be the base of our model, but I will keep the sketch visible because I want to keep extruding. So select the Extrude tool one more time. And now I want to extrude those walls. So something like this, and keep selecting more and more walls until I have all the walls selected. And this time I've used around 5 millimeters for the extrusion. Click the OK button, hide the sketch, and this is how it looks like. Now those dividers are there to stop the light spread from the surrounding segments, but at the same time there should be enough space for the actual LED strip to go around and inside. We are missing one part, and that is how to actually get the strip inside, so we are missing some kind of hole in this area. And I will add it again by extruding some elements, but this time set the operation to cut. We probably need the hole on the one side only, but I'm adding it on the other side as well to keep it symmetrical. I've decided to add one more feature, and there is a slight extrusion around the actual LED strip, something like this, in hopes that it will help me aligning this LED strip to be exactly in the middle. And so once this shape is done, it's time to export it as a 3D model by right-clicking on the body, which is this one, and selecting Save as Mesh, and save it as a 3MF file format. After that, it's time to open the 3D model in the Slicer application. I'm using the Bamboo Lab A1 Mini 3D printer, and the Slicer app is called the Bamboo Studio. And in here, I will select File, Open, and open the 3MF file. And as I open it, I will see this warning message saying that this model is outside of the printable area. So I just need to reposition it to the different position, or click the Arrange All button and arrange it on the printer plate. I will pretty much keep all the settings to default using the 0.4mm nozzle and the textured plate. The only thing that I will change is the filament, because I'm using the A1 Mini 3D printer together with the AMS unit, which allows to switch between 4 different filaments, and one of those is the PLA black matte, which I have currently installed on this slot number 4, so I'll select this one and then click the slice plate button. And I can use this slider to see how it is being sliced and how it will be printing, and you can see that there is this bridge over those two walls, but since this bridge is quite narrow, I don't think that we need to use any supports. So at this point, the only remaining thing is to print this by clicking the print plate button and click the send button, and as I do so, it will upload the file to the printer. And once it's uploaded, it will jump to the device tab, and I can click this play button to see the live stream from the webcam, which is being installed on the A1 mini printer. And as you can see on the left side, I was printing in many different colors lately, and this is the purged filament. So right now it's switching the different filament. After that it's preheating and doing some auto bed leveling. And then after about 5 minutes, it finally starts printing. And since this process takes about 26 minutes, let me speed it up for you. Also, as you can see, the image quality on the A1 Mini 3D printer is not the best, but it's still nice that you can see the progress on your PC or even on your phone using the dedicated application. And it will even send you a notification once the print is done. And it seems like that we are close to finishing our print. And this is how it looks like. Now it's time for probably the most time-consuming part of the process, and that is putting this LED strip inside. You first need to put the strip through the hole on one side. I'm using the left side. Then you remove the backing to expose the double-sided tape. Don't forget that one of those LEDs has to stay outside. Again, that's because otherwise we would be bending the strip on the position of those exposed connections, and that would be quite hard. And then I'm just bending the strip around those corners, going 90 degrees counterclockwise. And having this small extrusion in the middle of the base is definitely helping with centering the LED strip. I just need to make sure to not apply too much force on those corners to not break the connection. I mean not breaking the flexible PCB. And after a few failed attempts, I can tell you that once you start using some tools, even like for example a pencil tool to just push something inside, at that point I was usually breaking the PCB. So I'm trying to not use any tools and do everything by hand. And after a few minutes it might look like this. Now we need some kind of diffusers, but before actually printing the diffusers, let's try controlling those LEDs with Arduino. Again, I'm using the Arduino UNO board that looks like this. It's cheap, but the main reason for using it is because it's simple and very easy to use. To program it, you need to install and run the Arduino IDE. The Arduino IDE looks like this, and in here we need to first install the library for controlling those NeoPixels for those LEDs. So I will go to libraries and type in NeoPixel, and there are quite a lot of libraries. I'm using this one, which is called the Adafruit NeoPixel. I already have this installed, although maybe some older version. If you don't have it, you have to click the install button, and then you can go to File, Examples, open the Adafruit NeoPixel, and for example select the strand test. Because I already know that this example is just toggling some different variations of those LEDs for testing. Now what's important to us are those two defines. The first one is setting to which pin on the Arduino is the data cable being connected. By default it's set to pin number 6, and I think that we can keep it that way. The second define is setting how many LEDs we want to control, and if I count our LEDs we have 22 of those, so just change this to 22. Then make sure that the Arduino Uno is connected to your PC using the USB cable, select it from the drop-down menu and click the upload button. And the sketch is successfully uploaded, but we don't see anything because the NeoPixel strip is not yet connected to the Arduino. Now if you look at the Arduino, we have something that's called the female header pins, and if you look at the LED strip, we have some kind of wires. And while you can probably push those wires inside those female header pins, the connection will probably not be very strong and it will most likely fall off. Now you can of course solder male header pins to the LED strip, but I've said in the beginning of the video that I don't want to do any soldering, which means that I will use something different, and that's this screw shield for Arduino. You just snap it to the Arduino Uno and now you have access to both the female header pins as well as those screw terminals. So let's just temporarily disconnect the Arduino from the power source and then screw the ground to ground and 5 volts to 5 volts. And if you remember, in our code we were setting the data pin to pin number 6, which means that the data from the LED strip will be connected to pin number 6 on the Arduino Uno board. And with everything in place, we can again connect the Arduino to the USB power source, and now those LEDs are shining. And not just shining, they are also changing colors, showing all kinds of animations, even the rainbow effect, and testing if everything works. And since all our 22 LEDs are shining, I think that we can say that everything works as expected. Since we don't have the diffusers printed yet, let me just place this frosted acrylic so we can see those LEDs better. So I think that at this point, it's time to update the sketch in a way that we only light up some of those LEDs to form some digits. But I will actually not do this in the Arduino IDE. I will open the browser and go to walkway.com, which is a free online Arduino emulator, because now I can create a new Arduino UNO project by clicking the Arduino UNO. And not only I can simulate the Arduino UNO, I can also simulate NeoPixels, so I can just add the NeoPixel and simulate a NeoPixel this way. Unfortunately, I cannot easily add the LED strip, but I can just copy and paste it multiple times to somehow form our LED strip. And then I need to connect it to the Arduino UNO, and we know that the VDD should go to 5 volts, actually it's just lighting up for us. The VSS should go to ground, so ground should go to ground, and then this pin, the data pin for the first LED, should go to pin number 6. If I go back to the Arduino IDE and copy our example and paste it here in Walkway, I can try to run it, but it will show us that the library is not being installed, so click the install library and then run it again. And then you can see that the first NeoPixel is shining. Now if you want to collect more of those, you have to always connect VDD to VDD, so 5 volts to 5 volts, like so. So VDD going to VDD. And then all VSS, so all grounds, should be connected to grounds as well. And let me maybe actually change the color so we know what's going on. So this is the VCC for 5 volts, so let's just make it red. And this is ground, so let's just make it black. And then the Arduino UNO pin number 6 goes to the data in for the first LED. And from the first LED, there is a data out pin that will go into the data in of the second LED. And from the second LED, the data out pin will go to the data in on the third LED, and so on and so on. So if I restart the simulation now all those 3 NeoPixels are shining and changing colors. So let me actually add all 22 of those NeoPixels, and of course position them in a way that they are forming the 7-segment display with the one LED being outside. And connecting those NeoPixels is quite simple. Again, the data out from the previous LED goes to data in for the current LED. But unfortunately, all those connections, all those wires are being drawn over those NeoPixels. And once everything is connected, we can run the simulation again and see that everything works. But as you can see, those NeoPixels are not very visible below those connections. And I don't think that we need to have those connections visible, so we can go to the diagram.json file, and all those wires with the green color, we can just delete the green value, and it will make the connection invisible while still being there. However, without the connections visible, the shape of the 7-segment display is also less visible. So I've decided to do one more thing, and that is to draw the actual shape of the 7-segment display using the connection wire, something like this. So in the end, our sketch looks like this. So I think it's time to update the code to show those individual digits, so I'll jump to code, and let's start by simplifying the code and deleting the stuff that doesn't need to be there. And we will pretty much only need 3 functions. We need a function to clear all the pixels, and that function is called strip.clear. So I'll just copy this inside our loop function. Then we need a way how to set the pixel color, and that function is called the strip.setPixelColor. Again, I'll just copy this inside our main loop. And the final function that we need is the strip.show function, and that will cause the strip to actually show those colors. Anything else, I don't think that we need, so I'll just delete everything else. And we are left with a very simple sketch. First, we are including the library, then setting the data pin and the number of LEDs, and then initializing the strip. And then inside the setup, we are calling the begin function, which is required, and the show function that will turn off all the pixels. I don't think that we need to have this brightness function, I'll just delete it. And then inside the main loop function, we are clearing all the pixels, then setting some pixel to some color, and then showing this color on the LED strip. Obviously, we don't have the I variable, and we don't have the color variable, but let's just change it to NeoPixel with the index of 1. And as for the color, let's for example say 0xFFFF. That should hopefully be the white color, and restart the simulation. And I guess I was wrong about the color, but the second NeoPixel, the one with the index of 1, is being lit with the blue color instead. So let's open the Adafruit documentation and see some examples. And this is the thing that I'm looking for, so it looks like that I need to provide red, green and blue values, not just one value. And for the white color, it will be 255 for red, green, and blue channels. So hopefully when I restart the simulation now, the LED number 2 with the index of 1 is displaying the white color. But I will jump to the documentation again, because there should be a function to set the pixel color in the HSV color space. And that's this one, and it's quite helpful because we can get all those rainbow colors by just setting the hue and keeping the saturation and the value to maximum values. So here is the example that we are looking for, and actually I want this one, I want pure color, fully saturated and full brightness, so I can just use this example, only providing the hue value, and if I do it like this, I think that the hue 0 is red, so let me just double check, and yeah, the hue 0 is red. So if I go back to our simulation and then restart it one more time, indeed the first LED on our 7-segment display is now in red color. So I think that now we can light up multiple of those LEDs at the same time, and usually the segments on the 7-segment display are named A, B, C, D, E, F, and G like so. So I'll use the same naming in our comments, starting with the segment G, which consists of LEDs 1, 2, and 3. So 1, 2, and 3. And let's do a quick restart of the simulation. And the segment G should be shining. Then the segment B will be made from LEDs 4, 5, and 6. And maybe increase the hue to have a different color, for example, I don't know, 10,000. So now the segment B is in yellow color, and I will continue like this with all the other segments. So segment A is made from LEDs 7, 8, and 9, and so on and so on. At this point you can probably create some functions to draw those individual segments, but I've done something much simpler. Starting with the new variable hue, and that will be the type of unsigned integer, and I want to have the random hue that should go all the way to 65535, so all the way to 65535, and then I will use this hue in our color. Of course, add a small delay, for example half a second, and try to run it again, and now we should be getting random hues. And then I will just simply put all the code for each individual pixel only to one line, like so, and make it going from segment A all the way to segment G. In the end we have the same number of code, but now I can just easily comment out those individual segments, and by doing so I will not be lighting up some of those NeoPixels, and that way I can just create some digits. So this one right away is a digit number 8, and I'll just copy the whole block of code, which is probably not something that you want to do, but it should work. Let me actually draw those individual segment names, and if I want to display digit number 0, I don't want the segment G to be visible, so I will comment out the segment G. And if I restart the simulation now, I should be toggling between the digit 8 and the digit 0. So let's continue like this with all the other digits. And one more restart, and hopefully now the digit will count from 0 all the way up to 9 with having the random colors. And since this seems to be the case, let's try that also on the real Arduino. I will copy the code into the clipboard and paste it into the new sketch in the Arduino IDE, and then upload it to the Arduino UNO. And immediately we see those digits lighting up on our NeoPixel strip, which means it's time for the last step, and that's printing those diffusers. And I will print it using the white PLA filament, because I did find out that if you only print 1 or 2 layers, the white PLA is actually quite translucent. Obviously, the first step is to model those diffusers, and I will use the very same sketch that I was using for the bottom part. And first I will extrude all the segments with the 0.4 mm, because I'm printing with the layer height being 0.2 mm, which means that this distance will print 2 layers. Then I will extrude everything one more time. And here we want to set the extrusion to be as tall as possible, so the light is spreading as much as possible, but at the same time the bigger will be the height, the lower will be the brightness. And I did find out that about 12 mm works nicely and looks nice. Now for this extrusion I will select the type to be actually the thin extrude and set the wall thickness to be 1 mm, and by using these settings we get those hollow shapes. Obviously we will position those 3D shapes like this, like that. And if we want to push them all the way to the bottom, we need some kind of gaps, so we can just put the LED strip inside. So I've created a new sketch, and then again used the extrusion tool with the operation set to cut for having those holes. Now you might say that, for example, those holes and those holes are actually not very much needed because the strip will not go there. But again, I wanted to keep it simple and keep all the segments the same, so you can use whatever segment you want for any segment on the 7-segment display. And once those 3D diffusers are modeled, it's again time to export those in the FreeMF file format and open it in the Bamboo Studio. Then select all the individual pieces with the Ctrl key being pressed and move it to the center of the plate, like so. And of course, for all of those segments, I want to use the white PLA, which I've already preloaded into the AMS, so just select this one. And if you don't mind the textured feel, you can use the textured PLA plate, but I wanted the front face of those segments to be as smooth as possible, and for that reason, I've used the smooth PLA plate. Again, I've left all the other settings to default and clicked the slice plate button. There shouldn't be any surprise or bridges in this case, and I can just check with this slider that indeed we will be printing 2 base layers. Or I can even drag this slider, so 1 and 2, and now we don't see anything on the bottom, so we have 2 layers on the bottom, and there are no bridges, no gaps, so everything should hopefully print out fine. So let's do that. Let's click the print plate button and click the send button. And same as the last time, it jumps to the device tab. It will change the filament, do the preheating and auto bed leveling. And after about 5 minutes, it starts printing our diffusers. The most time is spent on printing those 2 bottom layers. And you will see that once those 2 layers are printed, it will be going pretty quickly. Obviously, I'm speeding it up. You can see on the bottom of the window that the whole print takes about 37 minutes. The reason for printing 2 layers instead of just 1 base layer is because 1 layer is kind of fragile. I've tried it and it was very easy to break the model. If we print more base layers, the light will be more diffused, but at the same time not as bright. And it looks like that our print is finished. And this is how those 7 diffusers looks like. So all that's left to do is to just snap those onto the base layer one by one. And after doing so, you can see that now it looks like the 7-segment display. It actually looks better in person. Somehow on camera those bright spots are brighter than in real life. I guess it's just the camera adjusting for different brightness for different colors. Now this extra LED is not shining, but it's still sticking out from our enclosure. I guess we can just bend it to be on the back side instead, and it looks much cleaner this way. Now I quite like this design, but I was thinking what if there will be some kind of black outline that will hold all of those 7 diffusers together. I think it will look even better without those gaps. Back in Fusion, I have used my original sketch one more time, and again using the extrusion tool, I have made this piece. That's pretty much in the same shape as the bottom part, but this time there are holes for those diffusers. And again, I've exported everything as a FreeMF file format and imported those objects into the Bamboo Lab Studio. Now, since I have the A1 Mini 3D printer together with the AMS unit, it means that I can print multiple colors at the same time. And to do that, I will click this plus icon to add one more filament, and I will use the white PLA matte filament together with the black PLA matte filament. And to assign a color to the geometry, I guess I can just right-click and select Change Filament and use our black filament for the outline. That will automatically place this purge object. I can as well go to the Objects tab and change the filament from here. But this is the correct combination that I want to use. And if I go to Plate Setting by clicking this icon, I can change the filament sequence for the first layer if I want to first print the white color or the black color. So if I first print the white color, like so, I can slice the plate and you will see that first those inner segments will be printed. Actually, I have to drag this slider to see that. So first the white segments will be printed and then the black outline. I can as well go back and change the order. So first will be the black and then the white. Click the OK button and slice it one more time. And again, if I drag this slider, you will see that first the black outline will be printed and then the inner part in white color. And then of course it will continue layer after layer. That said, I will rather print the white layer first and then the black layer. Again, click the slice plate button, and since I don't see any problems, I think it's time to print this in 2 colors. So click the print plate. It will take about 2 hours to print this model. So click the send button and let it print. And this is how it looks like after it's printed. And once you snap it onto the back piece, it just looks perfect. I mean, it just looks great. Now before I end this video, let me tell you a few things, some of them are quite important. Especially if you want to follow along and make your own 7-segment display. The most important part of this project is the used LED NeoPixel strip, and I've already told you that you can get those in different shapes and different sizes. But I haven't told you that you can also get those in different spacing between those NeoPixels. And usually the description will tell you how many LEDs are placed on 1 meter of the strip. And if you want to use my models, you have to buy the strip that has 48 LEDs on 1 meter. There is also a version with 60 LEDs on 1 meter, but that will not fit into the enclosure. I mean, you can adjust the enclosure, but that way it will be smaller. And obviously I wanted to make this 7-segment display as big as possible, but because of the 3D printer that I'm using, I wasn't able to fit 6 LEDs on 1 segment, even with the dense pixels. So that's pretty much the reason why I decided to use the strip with 48 LEDs on 1 meter. Let me again show you the metal version from PCBWay because that one looks great as well. And even when PCBWay offers 3D printing in metal, this is CNC machine with chrome plating. Now I usually record videos with every single step, and today I kind of went over the Fusion part pretty quickly. So if you want to learn more about Fusion, I have a few tutorials already on my channel. I will put the links down in the description. I also have some tutorials for NeoPixels, for those NeoPixel rings, as well as this hexagonal display. And finally, if you like segmented displays, I have a few videos on that topic as well. As usual, all the source files are on GitHub. And that's pretty much it for today. If you have any questions or comments, please put those down in the comment section. Thank you very much for watching, and I hope to see you soon. Thanks and bye.